Welcome back, guys, to our DSA challenge series. This is the phase 2 of our series, and the questions that we are tackling in this series are based on binary search and 2D arrays. The question that we are going to look today is median of two sorted arrays. In this, we are given two sorted arrays, nums1 and nums2, of size m and n respectively, and we need to return the median of these two sorted arrays. The question seems to be quite simple, but we need to do it in the run complexity of big O of log m plus n. There can be many approaches to solve this particular question, but we need to solve this question with the approach which takes the complexity of big O of log m plus n. So let us first of all understand this question with the help of example. Here we are given two arrays, nums1 and nums2. Nums1 contains 1 and 3, nums2 contains 2. So when we will merge these two arrays in the sorted order, the merged array will look like 1, 2, 3. And to find the median element, the total number of elements are 3, which is odd. So the median will be the middle element, that is 2. Similarly, in the second example, nums1 is 1, 2, nums2 is 3, 4. Then the merged array will be 1, 2, 3, 4 in the sorted order. In this, the number of elements are even, that is 4. So the median will be 2 plus 3 divided by 2, that is the sum of the middle two elements divided by 2, that is 2 plus 3 divided by 2, which comes out to be 2.5. So I hope the question is clear to you all. Now let us look at this approach. We are going to use binary search in order to solve this particular question. The very first step is going to be, we are going to use binary search to partition the smaller of two input arrays into two parts. We are going to partition the array into the two parts. Now we will find the partition of the larger array such that the sum of the elements on the left side of the partition in both the arrays is half of the total elements. Then in the third step, we are going to check if the partition is valid or not. If the partition is valid, we will find the median and return the answer. But for that, the particular condition is going to be if the largest number on the left side is smaller than the smallest number on the right. It means the partition is valid. And if the partition is valid, we will return the median. So I hope the approach is clear to you all. Now let us look at the code. The very first step that we did is in line number 4 is we have calculated the size of both the arrays, n1 and n2. For simplicity, we are considering that the size of the n1 array is less. If the size of the n1 array is less, we will directly continue to line number 10. If not, then we will pass the arrays as nums2 and nums1. Because the size of nums2 is left, so we will pass the arrays nums2 and nums1, and we will continue. In n, we have stored the sum of the size of both the arrays, n1 and n2. Then in line number 11, we have taken a variable left in which we have calculated the left partition size. Then we have initialized low and high as we are going to apply the binary search. So we have initialized low with 0 and high with n1. Then we have applied the condition of binary search by low is less than equals to high. Then we have calculated the middle indexes of both the arrays. In mid 1, it is the mid index of nums1, and in mid 2, it's the mid index of nums2 array. So we have calculated the middle index of both of them. Then we have initialized L1, L2, R1, and R2. Because there are two arrays, so L1 and R1 for nums1 and L2 and R2 for nums2. Then we have applied certain conditions to check whether the index is valid or not. If mid1 is less than n1, then the index is valid, and we will use R1 equals to nums1 at the index of mid1. N1 denotes the size of the array nums1, and N2 denotes the size of the array nums2. Similarly, we have applied the condition mid2 is less than nums2, N2. Mid1 minus 1 is greater than equal to 0, and mid2 minus 1 is greater than equal to 0. Because then only it will be a valid index. After applying these conditions, we have checked whether the partition is correct or not. We have applied the condition L1 is less than equal to R2, and then L2 is less than equals to R1. As we have discussed in the approach, the largest element on the left side should be smaller than the smallest element on the right side. So we have applied that particular condition. If this condition is true, it means the partition is correct. Then we are going to check whether the number of elements are odd or even. If n mod 2 double is equals to 1, it means the number of elements are odd, and we will directly return the middle element, that is the max of L1 and L2. Otherwise, what we are going to do, we are going to calculate the sum of both of these elements and we are going to divide it by 2 in order to obtain the median, because in the else condition will be executed if the number of elements in the array are even. If the partition is not correct, then we will check the condition L1 is greater than R2 and we will move towards the left side of nums1. Otherwise, we are going to move towards the right side of nums1. So I hope the question is clear to you all. And in this way, we are going to obtain the median element. We have returned 0. 0 will be returned in case the nums1 and nums2 that are provided to us are not sorted. So a 0 will be returned. So I hope the question is clear to you all. If yes, don't forget to subscribe to our channel and share it with your friends. Thank you.